If you're doing a confidence interval with a z-distribution instead of a z-distribution, then there's not too much that changes, but there is a little bit. Again, if you're using a t-distribution, that's because the population standard deviation is unknown and you have to estimate it with a sample standard deviation. So again, the formula is the sample mean plus or minus the margin of error. And now the margin of error is going to be your critical t, times the standard error. And now the standard error is going to be calculated with that sample standard deviation instead of the population standard deviation. So if we put that all together, we're going to have this sample mean plus or minus the critical t times the sample standard deviation divided by the square root of n. And so the lower bound is going to be the sample mean minus the critical t times the sample standard deviation divided by square root of n. And the upper bound is going to be similar, but a plus instead of a minus. You're going to have the same basic steps to the confidence interval. The biggest difference is we're going to have a critical t instead of a critical z in step 3. We're going to have a similar interpretation. And it's going to have the same number 7, but what's going to happen is that your confidence interval is going to be a little wider because when you use a t, the t value for the same confidence level is going to be higher than the z value for the same confidence level, and that's because we're going to have fatter tails for the t distribution over the z distribution. Here is a portion of the t-table, and the top of it has more degrees of freedom, and then it also has other things at the top that you can use for other purposes, but for our purposes right now, we want to know the confidence level and do a confidence interval. So the bottom is where you're going to find the confidence level, and then the first column is the degrees of freedom. So you take the n minus 1 to get the degrees of freedom. So say we have a sample size of 31, we subtract 1, we get 30 for our degrees of freedom. So we're going to go here into the first column and find the degrees of freedom, and then you're going to find your confidence level. So let's say we're doing 95%, then where those two things intersect is right here. So if we draw a line from there to there, and from there, you can see that it intersects at 2.042. So that would be the critical t we put in the formula for a 95% confidence interval when the population standard deviation is unknown and we have 30 degrees of freedom. Notice that the 2.42 is larger than you would have for a z-distribution. For a z-distribution, the critical z at 95% confidence is 1.96. So because that critical t is larger, our confidence interval is going to be slightly larger. But if you go, and actually you can kind of see that here, it also has the z's for the confidence levels. So for a z, it would be 1.96. So this might also be helpful for doing confidence intervals with the z-distribution. And you can also see that as the degrees of freedom increase, so we go lower in the table, then the closer that is to 1.96. So if you have 1,000 people or 1,001 people and your degrees of freedom is 1,000, then the critical t is 1.962, and that's not going to be much different than the 1.96 for the z-distribution. So the higher your degrees of freedom, the closer your t-distribution looks like a z-distribution. Now I'm going to show you how to find the critical t in Excel, because as you saw on the last slide, the critical t-table doesn't have every single degrees of freedom there are. And that's because that table would have to be really, really large. It's different than for the z distribution. For the z distribution, if we convert everything to a z, then most of the values are going to be between -3 and 3. I mean, there are some that are greater than that, but not too many. It's not going to happen a lot. But for a t distribution, we have so many degrees of freedom that you can't put everything on the table. So sometimes you might need to use Excel to get it. And I'll do it with the 30 degrees of freedom for 95% confidence. So you just want to pick a empty cell, doesn't matter which one. Just pick the first one. And you want to type equals t dot dis dot t dot inverse, or I and b. And see, it's kind of popping up. And you want to do a two tail because we have two tails. We put half of the alpha level on one side and half on the other side. So it's two-tailed, and then you're going to put parentheses, and then the probability is your alpha level. So we're going to put 0.05, and then your degrees of freedom. And in this example, we did 30, and then close your parentheses and then press enter. And there you go. You get the critical t, and that was what we got from the table. And this is going to be helpful when you don't have the exact degrees of freedom on your table. Now let's do an example. This is a very similar example from the confidence interval we did for a z distribution. So it says create a 90% confidence interval for a sample mean of 80 exam points. The sample standard deviation of exam scores for this class is 6 points. The number of exam scores is 36. So the only real difference is the 6 points in this example is calculated from the sample rather than the population. So keep that in mind. We see that it says sample, and we don't see anywhere the population standard deviation, so we're going to use a t distribution. So we're going to go through the similar steps. You need a norm population, or at least have n greater than 30. We have n greater than 30. We're not sure about the normal population distribution, but at least we have n greater than 30, and hopefully we have a representative sample, as I talked about before. We don't have a true random sample, but hopefully this is pretty representative of all my classes. So we're going to find the standard error, and it's really the same, besides we're going to use the sample standard deviation S instead of the population standard deviation sigma. So we're going to actually get the same standard error. Now, when you actually in real life, the population standard deviation and the sample standard deviation aren't going to be exactly the same. So just keep that in mind in this example. I just kept it the same to keep it simple. But in real life, it's not going to be the same. I just want to put that in there. And then you want to find the critical t. And we're going to go to Excel because the t table in this case does not have 35 degrees of freedom on it. It kind of skips over that. I'm in Excel, and I'm going to show you how to get a 90% confidence interval critical t for a sample size of 36. So first we need to find what alpha is. So alpha is going to be 1 minus your confidence level in proportion form. So we have a 90% confidence interval. So we're going to do 1 minus 0.90 because it's 90%. And we're going to take the 90% and move the decimal over twice to make it a proportion out of 1. And so we'll get 0.1 or 0.10. And then we need our degrees of freedom. And our degrees of freedom are and in this case it's 36 minus 1, so it's 35. And so to get the critical T for this, you'll push equals T dot INV dot 2T. Open your parentheses. The probability is going to be your alpha. You can type it out or you can just click on the cell that we have here. Comma, then it's degrees of freedom. Again, you can type out 35 or just click here. And then close your parentheses and press enter. So we have a critical T of 1.689572, and there you go. I found the critical T, and I'm just going to round it to 1.69. And now you want to find the margin of error, so it's just the critical T times the standard error. And so that's going to be 1.69 times 1, and that just equals 1.69. And we're going to find the lower limit, so the sample mean minus the margin of error. So 80 minus 1.69 is 78.31. And then find the upper limit. So that's going to be the sample mean plus the margin of error, which is going to be 80 plus 1.69, which is 81.69. And you can see the numbers are slightly different because we're using the T instead of the Z. In this case, it didn't make too much of a difference because we had a pretty good sample size. It's not extremely big, but it was pretty big, so it didn't make too much of a difference in this case, but sometimes it can make more of a difference. So we're going to say with 90% confidence, I expect the population mean of exam scores to be between 78.31 and 81.69. And you can see, given everything was equal, including the standard deviations between both of the examples, you can see that we have a larger confidence interval for the t distribution than over the z distribution. So you can see using a t distribution makes your confidence interval a little wider because the t critical is going to be a little bit larger than the z.